Okay, here we are. Sixth graders. Probably won't see this because I don't have to put it. I don't have to add every video. But if you're surfing my YouTube channel and you come across this, seventh graders or sixth graders, you guys won't. If a sixth grader is watching this, this won't be in your packet. The next two pages are page 7 and page 8 on the 7th and 8th grade packets are not on the 6th grade packets. So this video is just going to be page 7 in the 7th and 8th grade packet. I'm going to work my way through this, make the last video or make the page 8 video next. And then I thought about making a complete answer key and then have a video with me showing every page of an answer key. So if you wanted to double check to make sure that you had everything done, because I didn't cover every single, in the videos that I created yesterday, I didn't complete every single page. If you wanted to see what a completed measurement unit packet would look like, the next video will be that. Okay. Because we've already covered this, I'm not going to be as detailed as I did when we did the fraction equivalents in the last one. I'm just going to go through and fill this sheet out. So, and only using the 1/2, 1/4, 1/8, and 1/16. I don't know why I wrote that one so big. So only using these denominators will I'll put the equivalent fractions to this here, and I'm not gonna explain that much on how it goes through. I'm just gonna go through and do it. So 1/8 equals 2/16, 1/4 equals 2/8, and 4/16. 3/8 equals 6/16. 1/2 inch equals 2/4, 4/8, and 8/16. 5/8 equals 10/16. 3/4 equals 6/8. 7/8 equals 14/16. If you wanted to figure out how to do that, if I did that super fast and you weren't able to figure out and understand it, whatever I multiplied the denominator to get my equivalent fraction, you're going to be using the that same number to multiply the top number. So 2 times 8 equals 16. 2 times 1 is 2. 2 times 4 is 8. 2 times 1 is 2. 4 times 4 is 16. 4 times 1 is 4. 2 times 8 is 16. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 4 times 2 is 8. 4 times 1 is 4. 8 times 2 is 16. 8 times 1 is 8. 2 times 8 is 16. 2 times 5 is 10. I guess I forgot one. I'm glad I double checked this. 2 times 4 is 8. 2 times 3 is 16. 4 times 4 is 16. 4 times 3 is 12. So 12/16 should be another one we have there. Okay. So 8th graders, you will, when you guys get done with your projects, I have you guys do a self-evaluation. And in order to do that, you have to know what tolerances are. And so what tolerances are, let's say that you have a project that is, let's say you have a project that requires a board to be 5.5 inches long. And when you get done making it, you end up having a board. The requirement is 5 required. Required is 5.5. And your let's say our actual one that we do might be 5 9/16, because that's 1/16 away from that. We're going to need to know, based off of however many points for a tolerance is, we would need to know how to subtract that. That's not really explaining what a tolerance is, but this is how you're going to figure out the points, how to figure out tolerances with that. So basically what a tolerance is, if you think of like a door frame, okay? So if I were to, let's flip this around so I can kind of explain with this. So the door frame behind me right here, okay? This door frame. This door is actually more narrow than the span of the door frame itself. So if we were to measure that door, if this is a 36-inch opening, which I don't think it is, it might be a 32. It's probably a 32. But if at this opening, usually the doors are about a 1/4 inch less than the width of the door, meaning that if I measured the door would be, if it's a 32-inch frame, it would be 31 3/4. And then the frame of the door would be 32 inches exactly. What a tolerance is a tolerance is the difference between something that fits into an object to the size of the larger part where the objects fit into. So the tolerance for this door, if the door is 31 3/4 and the door frame is 32 inches, the tolerance would be a 1/4 inch. And when you make this part, that would make an 1/8 of an inch gap on this side and an 1/8 of an inch gap on that side of the door. So you take that tolerance and you split it between, when you have an object that's going to fit inside. So like, let's say if I had a span right here and my fingers are going to fit in, the tolerance is divided between the spaces of your whole object. Or maybe we'll just do my finger like this so it's a little bit easier to see. Man, I'm very white. I need to find the right shadow. So tolerance is the space in between the smaller object fitting inside the larger object. So the extra space that's left over between there, I'm trying to make it so you can kind of see it. It's sort of not working, but. So the tolerance is that space in between the object that fits into the larger object. That's basically what that is. So when you create something, not everything will, especially at your age, when you guys are in middle school and you haven't created a whole lot, you might have things not be the exact size. The only time I take off parts to a specific degree is for the 8th grade projects. For the 7th grade projects, it's more about visual aesthetic. It's not necessarily about the measurement so much. We still have to measure to make things fit together. But if you're done, or when you're done creating the project, if it's not the exact measurement, I don't go into that much detail to determine how much your projects are worth or how much you've earned. It's mainly on aesthetic, the aesthetic value, I wouldn't say the value, but just the way that it looks is is what I use to judge how it gets graded. So for the 8th graders, when you guys get done with your first project in your green book, you're going to be, I know I have one inside my house because I haven't burnt trash with all of the leftovers from. We just got done with Q1, so I have a bunch of evaluation papers in my recycling right now. And so I could run and get that, but I don't really want to. I want to try to work on getting this finished because I have one more page to do, and I probably have 2 more videos to do. And so we'll see how she goes. I want to try to get everything done and uploaded to the classrooms by 8 o'clock if I can. So here we go. I'm going to flip this camera around now that I've kind of gone off that tangent on what tolerances are. So we're just going to go through and work our math on the paper. You don't necessarily have to understand everything there is to understand about tolerances. We just have to work through the math on here. I'm sorry, I'm very tired right now, so I'm not thinking the clearest in terms of teaching you guys right now. I'm just trying to get through this here. Okay. It's been a long Friday right now. Seems like it was a long time ago. because that's when my marathon of no sleep started, when Annie started to get sick. And the virus has got to be getting close to its end, so we'll see how she goes. There you go. So in order to subtract and add fractions, we have to have the same denominator, and we're gonna help with that on the last lowest portion on the paper here. Let's try to make it so that I can see all of the bottom half of this all at once. Okay. So give the tolerances if your tolerance was plus or minus 1/8 of an inch. So you can either be an eighth of an inch above a listed. That's one of the things when it says tolerances. Usually you're going to see a plus or minus and then a fraction next to it. So if we had a tolerance that was an eighth of an inch, so like if your goal was to, what we're going to basically do is we're going to get an acceptable measurement. So if you were to create something and you have an eighth of an inch tolerance, if you made it an eighth of an inch less or an eighth of an inch more, or an eighth of an inch less, then you're finished. You wouldn't lose any points. But here we go. Let's try to get it to fit there. Okay. Trying to get my camera to stop shaking. In order to add and subtract fractions, your denominator needs to be the same. If your denominator is the same, when you add it, or when you go to add, all you have to do is add the top numbers. So we know that our answer is going to have an eighth, and we'll talk about reducing when we go through this. So we know when we're adding and subtracting these fractions, if the denominators are the same, when we get done adding this and subtracting these, we'll know what we can write for our denominators right away. So 3/8 plus 1/8, once we have our denominator written, we can do our top. 3 plus 1 is 4. Can this be reduced? Yes, it can. They both can be divided by 2. They also can both be divided by 4. If you wanted to take the long way, if you're not sure about how to reduce fractions, just divide them by 2 until the top number is odd. So if we divide both of these by 2, you would get 2/4. If you divide them 2/4 by 2 again, you'd get 1/2. So 4/8 or 1/2. When you're subtracting, you're going to go like this. So first we're going to write the eighth right here. 3 minus 1 is 2, or 1/8, because that equals that, because what we did up here. But that's that. I'm just kind of running through the math. Not doing a great job explaining it because I'm very tired, but here we go. In order to add and subtract 1/16 from 3/4, we have to change 3/4 into 16. We could go through that, but if we have it done above us, 3/4 equals 12/16. So before we start adding this, we're going to change 3/4 to 12/16. Whoops, I don't know why I'm doing that. Man, I'm tired. 12/16 plus 1/16 equals 13/16. Okay, that one's done. We're going to do 12/16 minus 1/16. So this should be 13/16, by the way. 12/16 minus 1/16 would be 11/16. Give the tolerances of the measurement. Oh, gosh, this thing is so wiggly. I just bumped the base of it and it started wiggling. It's like it has Parkinson's almost. Just the way that it looks. I'm not trying to be offensive. I'm just saying that the camera is shaking like someone that might have Parkinson's. Here we go. This video is getting way too long. We got to finish this up. 13/16 minus 1/16 would be, or 13/16 plus 1/16 would be 4/16. If we were to reduce it, we would write 1/4. 13/16 minus 1/16 would be 2/16 or 1/8. Half inch, before we add and subtract, we have to convert this to a 16th. If we look up above, it would be 8/16 plus 1/16 would be 9/16. If we had 8/16 minus 1/16, so we have, there's only 1/16. Man, this writing is bad. 1/1/6 equals. So we basically are going to do 8 minus 1 is 7. So 7/16 is 1/16 of an inch less. 7. I don't like the way that this ends up looking when I do that. 7/1/6. That looks better. 7/16. There you go. And again, I'm going to have another video that will be an answer key video to all of it to help a completed version of it. And then you'll be able to pause every single one to make sure it looks the same. Okay. But there we go. I'm trying to make it so I can see the whole thing. That's done. Make it focus first. That glare is making it so it's hard to see. What if I shut this off? There we go.